A customer wants to install a PV system over the roof of a single-story factory with very low carbon emissions. The location is near to Jandakot Airport in Perth, Western Australia. He would like to cover 80% of his daily consumption. By surveying the location, we found a building of 30 by 50 meters area and 50 meter height. It's 10 meter in front of the factory and it's also 15 meter in the right direction from the factory. We will use this in shade analysis. The factory is also 30 by 50 meters and 20 meters height. The roof tilt is 29 degrees and it has zero orientation in a very good position facing the equator. The yearly consumption is 24,000 kilowatt hour. The customer wants no more than 10 years of payback period. That is his requirement. We eventually need battery system, as it's 80% of the load of the day, so it also covers the night load. Also, we should expect very little payment during the assessment period from the grid, as it only covers 80% of the load and the assessment period is 20 years also. Actually, this location is also as the same in the previous lab, as the sun reaches its peak too often yearly, so we won't oversize the panels and lose a lot of its power during peak. Let's start. The average daily consumption is 24,000 kilowatt hour divided by 365 equals 65.75 kilowatt hour. Then we want 80%. It's 80% multiplied by 65.75 equals 52.6. Then divided by the efficiency of the DC line, it's 65.75 kilowatt hours again. Now we go to the place or the location in Solar Atlas. Here is where it's closest to the location. Per day GTI is 5.977 kilowatt hours per meter square. Let's say it's 5.9 kilowatt per meter square, then divided by 1000 watt per meter square. And the peak sun hour would be 5.9 hours. Then to get the peak, the panel's peak, it's 65.75 divided by 5.9 and it's 11.14 kilowatt peak. Then the number of panels needed is 11.14 multiplied by 10 power 3 divided by 300 if we use 300 watt peak panel equals 37.14 or 38 panels. Through surveying, we knew that the consumption takes the same profile as a house with evening peak, due to the machines that are turned on at night, and during weekends they do maintenance, so the consumption drops to 50%. You can get it here through multiplying the day with the heaviest night load by the average daily consumption. When you use a night load is 41.4225 kilowatt hour approximately through surveying. Also, we decided to use 15 by 12 or 15 batteries connected in series in each string, each is 12 volts. So the ampere hour minimum is 41.4225 multiplied by 10 power 3 over 0.7 by 15 by 12 equals 329 ampere hour C10 rated. And the usable energy is 41.4225 kilowatt hour, as we said. Let's create the location and say we need 230 volt and 3 phase grid. Now let's define consumption. Then we move on to the 3D system